Okay, I guess I can record it now. So let's move on to section 2, chapter 11. Let me try to share the screen with you. I haven't heard from the tech person yet, so I don't know exactly what's going on. But we will see. Okay, so we are talking about curves, polygons, and symmetry in section 2. First one is the curves. In real life, let me present this. When we're talking about curves, then we think something like a curve, not straight lines, right? But in mathematics, we include all of that, like straight line, or even the curve that you're thinking about too. So when you're drawing a path without lifting the pencil continuously and without retracing, without going back the part where you started or going back to where you already drew the path, that is called a curve. Okay, so here is the Khan Academy video that I really wanted to watch. So let me turn this back, turn this on for you. And that link is also given to you, so you can copy and paste it to watch it.
Have you ever been in class and you begin to get a little bit bored? So you start daydreaming, and all of a sudden, you notice that your hand has a life of its own, and you start drawing something on the corner of the textbook somewhere. And maybe you draw something more beautiful than this. But what you've just done here is draw what in maths we call a curve. So what is a curve? Almost anything you do on a piece of paper, where you start somewhere, you do something, and then you stop, is a curve. So if I do this, then I've drawn a curve. Almost anything you do. So then what is not a curve? If I draw a circle, have I drawn a curve? Yes, I have. I've started from a point, gone, and stopped. Now what you notice here is in all these cases, I didn't have to take my hand off the piece of paper. I could just start and do the whole thing. So all of these are curves. But if I now add, maybe I don't know, this looks like a face to me. If I add 2 eyes over here, then what I've done is that I have made this have gaps. So you can see the gaps here. You cannot go from this part of this picture to this without taking your hands off. So this gap, let me mark it out over here. This gap is also called a discontinuity. You can just call it a gap. So if there is a gap, then it's not a curve. So if you want it to be a curve, then it has to be what we call continuous. So maybe if I do this, if I take this and if I connect it with some specs, if I do this and then connect it like this, then what I have is a curve. But if I have that gap, then what I have is not a curve. Now what if I draw a straight line? And then if I ask you, is this a curve? What would your answer be? Think about that question. In daily life, we keep saying that a road can either be straight or it can be curved. But in maths, look at what we said. If you start somewhere and go somewhere else, and then you stop, as long as you know there are no gaps, what you've drawn is a curve. So then, is a straight line a curve? Yes, it is. Even though in daily usage we don't call it a curve. So you can see that in maths, some of the words have different meanings than what they have in normal language. So if this is a curve, if one line is a curve, then think about this. If I take it, draw one line like that, and then draw another line like this. Is this a curve? I'm just marking these corners big. This could have just been drawn like this. So this is a curve. This is a curve. These are almost same. Maybe I'll do this. Is that a curve? Yes, it is. I started somewhere, and there are no gaps between each of these lines that I've drawn. I can even make this bigger. I can draw something like this. Maybe a kite. This is also a curve. So just because we use the word curve, a lot of people think that the lines should be curved like this and cannot be straight lines. In fact, they even say you should not use the ruler. You use whatever you want to, but make sure that the whole thing is connected or continuous. And now that you know what a curve is, maybe we can begin to play with it. If I take you down here, and if I ask you, okay, you see some curves over here on the left and some more curves over here on the right. Can you take a minute? Just pause this video now. Take a minute to see, is there a difference between these two? And if so, what is that difference? Now, if you thought about it, you may have noticed that in all these curves on this side, you never see what we can call a crossing. So to draw this curve, in some sense, you have to go like this, go all the way here, and then cross yourself at this point. But you don't see that happening anywhere over here. Over here, again, you can see that there is a crossing. And then here, where is the crossing over here? It's right over here. Here it's over here. Now, on this side, no matter where you draw whatever you're drawing, you can just draw it completely. You'll notice that all the curves that do this, in other words, they don't cross, are called simple curves. S-I-M-P-L-E, simple curves. They don't cross themselves. And those curves that do cross themselves are called, at least I'm going to call them not simple curves. Not simple. Maybe there's a more serious sounding name for this, but I guess they should do. Now, what's these two last diagrams over here? If you look at them, to draw them, I actually don't have to cross, right? I can just go like this, go here and come here. So we've used the word crossing, but there is a better way to say the same thing. So what is it about these not simple curves that you should know? The idea is that anytime you pick a point over here, maybe I pick somewhere here, maybe I pick this point. If you look inside, you can see that there are only two lines leaving from this point. If I pick, say, this point, I can see there are two lines leaving from that point. So anytime that I pick anything that I want, even in between, I can just pick a point over here and say there are only two lines going over here. In fact, you might have even asked, isn't this crossing itself in some sense? Because I start somewhere here, go all the way, and then I have to come back to the same point, right? That happens in all these cases. Whenever you do that, even if you do that, it's still a simple curve. But if you can ever draw, say, a circle and find that inside this, if you take a point, there will be 3 or more lines coming from there, then it's not simple. Right? So I hope you can see that difference. Over here, if you draw that circle, if you take this point, how many can you find? 1, 2, 3, 4. 1, 2, 3, 4. Even if it's not 4, even if it's just 3, that's enough. So over here, you can see that there is 3. That's enough to make the curve not simple. When I was in school, I remember that I used to have one favorite curve that I used to keep drawing on my textbooks and get scolded. So my curve was this. I used to love drawing what I think it's called a spiral, and it was always very fun, a lot of fun to draw, especially because I used to find it hard to keep this gap between the two lines the same. And the reason I used to love drawing this is because once I finished drawing it, then I could look at it and it looked like it's rotating. I don't know why that happens, but it used to look like it's rotating even though it's not. Oh, it became ugly over here. Now the question for you is, what I've done here, have I drawn a curve? Is this a curve? In other words, are there gaps in this or not? Also, is this a simple curve or a not simple curve? Not simple curve. Think about that question.
Okay, so what do you think? Is that a simple curve? I mean, is that a curve or not curve? Is that a simple curve or not a simple curve? Well, we can think about any point on that line. Of course, it is a curve because he didn't lift his pencil up, right? Continuously going on and on and on. So it is a curve. And whenever you pick any point on it, there are 2 lines that connects that point, right? So it is a simple curve. So we got the idea about what is a simple curve and what is not a simple curve. So going back, I want to make sure I am sharing this. So let me check. My Zoom. Am I sharing correctly? I hope I am. Let me see. Yes, okay. Okay, so a simple curve is a curve that does not intersect itself, except the starting and stopping point may be the same. It works because whenever you pick a point here, on the other side, there are 2 lines. So when you have only 2 lines on the point on both sides, it is a simple curve. Here too, it is a simple curve, right? So 2 or 1. At this point, you have only 1 line. So it is a simple curve. This is not a simple curve because when you pick this crossing side here, crossing point, you have 4 sides going out from that point. So it is not simple curve. Okay, and some curves, whether it is simple or not, you can think about it's closed or it's open. So some closed curve, it's very simple because we know what closed mean, right? It is closed here, nothing can come in, right? So it's closed, and this is also closed, but this is a little bit different from the other two. So we're gonna talk about it, that too. Oh, I didn't hear. So this is complex curve, but we're going to talk about that in the polygons. Okay, so we talked about simple curve and closed curve. And we're going to move on to polygon because polygons, we're talking about the curves and closed, but the curves is special here. The polygon has to be straight curve, so straight lines only. Okay, actually it's a line segment because there's endpoints, right? So polygons have to be straight line segments and has to be closed. Okay, so like this one, it is polygon because as you can see, it is all closed and everything, every edge is straight, right? So it is polygon. How about this one? It is closed, but it's not straight here. It is curved, right? Round. So we cannot say this is a polygon. This is not a polygon as well. Every edge is straight, but it's not closed. So it's not a polygon. Okay. In polygon, you also have to know some terminologies, of course. So vertex, the plural form is vertices, is a point where 2 or more line segments meet. So this is a vertex in 2-dimensional polygon, and here 3-dimensional. Whenever you have the edges meet together, the line segments meet together, that's a vertex, that's a vertex, that's a vertex, and so on. And edge is the line segment that joining two vertices, right? So this is edge, edge, edge. Sometimes we call this side, but edge is more accurate term because what about this one in 3-dimensional? That brown part here can be side too. More precisely, we call that face. In this line segment, we call that edge, okay? So try to use those terminologies. So in polygons, you can also separate concave polygon and convex polygon. Concave, it's caved in, okay? Like this one is caved in. Convex, it cave out, it goes outside. So convex polygon, it goes out. And think about all of these interior angles. No internal angles is greater than 180. Take a look. If you have a straight line here, you can have 180 degrees, but this angle here is less than 180 degrees. All of them less than 180 degrees. So they are called convex. Okay. How about this one? This is less than 180, less than 180, less than 180, less than 180. But this internal angle here, this is greater than 180 degree angle, right? So it's a concave. You can also always think about the concave, the caved in, okay? So you need to know how to distinguish convex with the concave. And another name for polygons is regular polygon or irregular polygon. Regular polygon is like this. Okay, so when you see the side, the edges, the length of the edges are all equal. So we call that equilateral. Equilateral. Also, the angles are congruent. All of these 5 angles are congruent. So equiangular. So regular polygon is a polygon, so straight lines and closed, right? They have to have same length about the edges and same angles about the interior angles. Irregular angles, at least one of the angles or one of the sides is different from others. So you need to know regular polygon means all edges are congruent and all angles are congruent. Otherwise, it's irregular. And simple polygon or complex polygon is another category that we can talk about. So simple polygon is the polygon with only one boundary. So you can see there's only one polygon. For complex polygon, you can see actually there are two polygons compounded together, right? So we call that complex polygon. So there's intersecting parts. Okay, you can see that this part is a polygon because it has a straight line and closed, and this one too, straight line segments and it is closed. But there are more than one simple polygon, so we call it complex polygon. Okay, and more examples here. You need to talk to me. I wish we can interact here, but what do you think about this one? What kind of polygon is this? Ponder it. How about this one? Simple or complex? Is it regular or irregular? Think about it. Okay, same for this one. So this is irregular because these sides are not all congruent, right? The lengths are not congruent, so it is irregular. Of course, the angles are not congruent as well, so it is irregular. I call that hexagon because we have 6 sides or 6 interior angles. 6 angles, 1, 2, 3, 4, 5, 6. So hexagon means 6 sides or 6 angles. This is octagon because you have 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. It's octagon. It's irregular as well because this length, of course, is longer than this side, right? So it's not equilateral. So it is irregular octagon. Especially it is also concave. It's caved in. This angle here is greater than 180 degrees. How about this one? It's convex. There's no angle, no interior angle that is greater than 180. How about this one? It's complex polygon because there are more than one polygon. Here's triangle, triangle, pentagon, triangle, 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 right? This is, what else? Yeah, because it's a complex, you cannot just determine whether it is concave or convex. If you're looking at only outside without looking at these lines here, what do you think? It is concave because looking at this angle is greater than 180 degrees. With these lines there, it becomes complex polygon. Okay, let's take a look at this interactive polygons a little bit. So this site, I like it so much because it shows the name and it shows the category too. So it says regular pentagon. Regular means all sides are congruent. So as you can see, the length around the shape, the sides, all the edges are congruent and all the angles, interior angles are also congruent. So it is regular. And it is a pentagon because you have 5 sides. If I change that to 4 vertices and 4 sides, then it becomes a quadrilateral. Especially this is a square because you have all congruent angles and you have all congruent sides. If I make one side longer than the other, it is also quadrilateral, but it's not regular. It becomes irregular quadrilateral. Right? If I make it bigger like this, hexagon, because I have 6 sides, and all of these sides, the edges are congruent, so it is regular, right? If I change anything differently like this, yeah, it becomes concave. This angle is greater than 180. And this is a heptagon because I have 7 vertices. 1, 2, 3, 4, 5, 6, 7. 7 vertices, heptagon. Okay, this is concave. Now it's convex heptagon, right? It's not regular anymore because this size is longer than the others, right? Okay, so you can play with this with your students too. Okay, did I skip anything? Here. Okay, so polygons. Polygons are classified according to the number of sides or vertices to have. We just take a look at some examples, right? We looked at quadrilateral, we looked at hexagon, heptagon, and so on. So the names are coming from number of sides or number of vertices. Triangle, you have 3 sides. Quadrilateral, 4 sides. Pentagon, 5 sides. Hexagon, 6 sides. Heptagon, 7. Octagon, 8. Like octopus, octopus has 8 legs, right? Octagon. Nonagon, 9 sides. Decagon, 10 sides. Hendecagon, 11 sides. The decagon, 12 sides. So I want you to remember at least up to decagon. We don't usually use 11 sides much because it's hard to construct, but to 12 we do use a lot of times. More than 12, it's hard to name all of that and hard to remember them, right? So we just say that n-gon, like 13, we say 13-gon, 14 sides, we say 14-gon, and so on. Okay, when referring to polygon, we need to list the name. So instead of saying, oh, there's an orange quadrilateral, we can say that, oh, that's quadrilateral A, B, C, D, or quadrilateral A, B, C, D. I haven't mentioned that before. You need to go in consecutive order. So if you start from vertex A, go either direction, it doesn't matter, but you cannot skip that vertex and go to next. Like you cannot say quadrilateral A, C, B, D, things like that. You can't, right? You need to go in order A, D, C, B, or quadrilateral A, B, C, D, or you can start from different vertex like D. If you start from vertex D, you can say this quadrilateral D, A, B, C, or D, C, B, A, things like that, okay? What is an interior angle? We have talked about that too. It's an inside of the angle of the shape. So when you're looking at this, what is it, pentagon? Because there are 5 sides. In this pentagon, you can see these are the interior angles. And what's exterior angle then? Exterior angle, you extend that side and look at the supplementary part, right? So that's exterior angle. Diagonal, what is diagonal? From one vertex, you can draw a line segment, but that's not, consecutive vertices. So because there's already an edge, there's a side there. So diagonal, not that vertex is connected with this vertex, but you wanna connect this vertex with other vertices, not consecutive vertex, okay? So we know what diagonal means. What does congruent mean? Congruent means whether you are, turn it or flip it or reflex, whatever you're doing, the shape does not change. So the shape does not change, but also the size doesn't change. So for congruent, you need to remember 2 things. What are the same? The size should be the same. Also, the shape should be the same. Shape should not be changed and the size should not be changed. When we are talking about size, we are not only talking about the length, but also talking about the angle measurement too, right? So remember that. Whenever you're looking at this one, sides are congruent. These 2 sides are congruent. So line segment AB and line segment CD are congruent because their measurement is equal. Okay, listen carefully. I just said segment AB and segment CD are congruent. So segment AB and segment CD are congruent. We're using this congruent notation because the measurement of the length of segment AB and length of segment CD are equal. I just said AB and CD are equal. So without the segment notation, you need to put equal sign for the measurement of the length. Okay, so AB is equal to CD. Do you see the difference? I've mentioned that before in class too. So segments are congruent because we're talking about the shape. but the length are equal because the sides should be the same. Make sense? Look at the angles too. So we know this angle XYZ is congruent to angle PQR or angle RQP. It doesn't matter whichever direction you go, right? Just make sure your vertex goes in the middle. Q or Y is in the middle. These two angles are congruent. Two angles are congruent because their measurement of the angle is equal. Okay, so when you're writing the notation, pay much more attention to that. So again, the angles are congruent because their measurement of the angle is equal. Okay. Okay, regular polygons, we have talked about that earlier, right? Regular polygons have same length of the edges. Also, they have the same measurement of the angles. So when they have same measurement of the length, it is equilateral. Equilateral means equal length. Equiangular means it's equal angle. So this is not a regular polygon because of course this is too long, right? The angle is not all equal and the sides are not all the same. So it is not a regular polygon. How about this one? This picture is wrong because this length. Oh, actually, I'm sorry. I think this is not right. Let's see. Is this a regular polygon or not? This is not actually regular polygon. We need to cross that out because even if the angles are all congruent, so it is equiangular. However, it is not equilateral. So this length is so much longer than these four lengths, right? It is not equilateral. So we cannot say it is a regular polygon. We need to put that as irregular. So cross that out, okay? Make sure it is irregular. I'm gonna check that when you're showing me your notes, okay? How about this one? It's not equilateral or equiangular. Tell me. Well, it says these lengths are all equal. So it is equilateral. It is equilateral. Oh, this is wrong. I need to change that, right? Equilateral, but the angles are not the same because this is smaller than this. Not equiangular. So we need to say it is equilateral, but not equiangular. So it is not a regular polygon. So to be a regular polygon, both has to meet. The angles, all angles have to be congruent, equiangular, and all the length has to be the same, equilateral. So this is a regular polygon, not a regular polygon, not a regular polygon, not a regular polygon. Okay. All right. So we know the names of that, and we know the number of size for each of these names. And here are some examples of the shapes, right? We can also think about if this is a regular polygon, if it's a regular triangle, which means equilateral triangle, then the angles are all 60 degrees angle. All interior angles are congruent as 90 for quadrilateral, 108 for pentagon, 120 for hexagon. So we can see that as the number of sides increases, what happens? The measure of interior angles also increases. So if you keep adding more and more sides here, it's getting very similar to a circle. An interior angle of the circle, it's going to be very, very big, right? Okay, so we can take a look at that. I think we're going to have some time to calculate these interior angles later. Okay, so what is a triangle? Triangle, you have 3 sides and 3 vertices, right? So the figure formed by 3 segments joining 3 non-collinear points. If the points are collinear, it becomes only one straight line. It's not gonna make a triangle. So you need to have 3 non-collinear points. And each point is a vertex, right? And the segments are the sides or edges of a triangle. It is okay to say side because we're talking about 2-dimensional, but when you move on to 3-dimensional, make sure you write edge instead of sides, okay? So triangles can be classified by number of congruent sides. Well, there are different classification too. We can classify the triangles by the measurement of the angles too, but now we're gonna focus on the size of the triangle. So like this triangle, there's no congruent sides. This side and that side, all of these 3 sides have different length. Okay, so we call that scalene triangle. Isosceles triangle has 2 sides that are congruent, but the third one is not congruent. So only 2 sides are congruent, then we call that isosceles triangle. Okay. If you have all 3 sides congruent, we call that equilateral triangle because all of the sides are equilateral. Okay. Okay. And think about classifying the triangle by angles this time. So we know angles can be classified by whether it is greater than 90 or less than 90 or is it 180 and so on. You cannot think of above 180 degrees angle for triangle because the sum of the interior angle of the triangle is 180. It cannot be, one angle cannot be bigger than 180. So if all 3 of these angles is acute angles, which means less than 90-degree angles, we call that it's acute triangle. If at least one, just one angle is greater than 90-degree angle, it is obtuse triangle. If it is right angle, which is 90-degree angle, we call that right triangle. Okay. So for this triangle, it's equiangular triangles when all of these interior angles are congruent. So quadrilateral. Quadrilateral is the name for the polygon with 4 vertices and 4 sides, right? So quad, we know that means 4. Lateral means size, length, right? So 4 sides. Okay, there are properties for quadrilateral. We know quadrilateral has 4 sides and has 4 vertices. That's good. Another thing that you can remember is interior angle. The sum of the interior angles of a quadrilateral is 360 degrees. What is the sum of the interior angles of a triangle? Yes, 180 degrees. Nice. So quadrilateral is a little bit complicating because there are so many different names in it. So one, the first thing you want to learn is rectangle. A rectangle, take a look at the word, rect, angle, rect, right angle. So rectangle is all 4 angles, interior angles are 90-degree angles. Then we call that rectangle. It doesn't matter about the length of the sides, okay? But we're talking about only the angles. If all 4 angles are 90-degree angles, it is rectangle. What is a square then? Square, we are adding another thing. Not only the angles are congruent as 90 degrees, but also the sides, all 4 sides have to be congruent. Then it becomes a square. So we can make a comment here then. Think about it. Are all rectangles square? Are all rectangles square? No, not really, right? Because like this one, these angles are congruent, so it is a rectangle, but these 2 lengths are not the same. So this specific rectangle is not a square. But take a look at this. Are all squares rectangle? Yeah, all squares have to have 90 degrees on all 4 corners, right? All 4 angles have to be 90-degree angles. So it is a rectangle. So all squares are rectangle, but not all rectangles are square. Make sense? Okay. Okay, so since square has the properties of a rectangle, and also it has a property of a parallelogram. Parallelogram has two pairs. So this and that pairs are parallel, and that pairs are parallel. And also their lengths are congruent. So this pair is congruent and this pair is congruent. Okay, so you need to have the characteristics of parallelogram. You also need to have characteristics of rectangle. It also have a characteristics of rhombus, because rhombus is quadrilateral with all four sides congruent, regardless of the interior angle. Okay, that's rhombus. Only four sides are congruent. Usually we use like a kite. Kite is one example of rhombus. All four sides are congruent. Okay. Also here, the rhombus. Rhombus definition is all four sides are congruent. It doesn't matter whether the angles are all congruent, but opposite angles should be congruent. Opposite angles should be congruent. Okay, so rhombus is when quadrilateral has all four sides congruent. We call that rhombus. Okay, and of course, opposite sides are parallel and opposite angles are congruent. When you're drawing diagonal, I didn't draw diagonals here. Diagonal, here's one diagonal, there's another diagonal. They intersect at 90-degree angle. That's one important property that you have to remember for rhombus. Okay, and parallelogram is parallel. So opposite sides are parallel. These two sides are parallel and these two sides are parallel. Okay, and then of course these two parallel sides are congruent and these two parallel sides are also congruent. What if you have only one pair that are parallel? It becomes trapezoid. Trapezoid, at least a pair of opposite sides are parallel. So if you have only one pair that are parallel, like this and or like that, they are called trapezoid. Then think about it. How about parallelogram? Parallelogram has to have two pairs of opposite sides that are parallel. So all parallelogram is trapezoid, but not all trapezoid are the parallelogram. Okay. Trapezoid has special, there is a special trapezoid called isosceles trapezoid. What is isosceles trapezoid? When you have this non-parallel sides that are congruent. So the length of these two sides are congruent and their angles here are congruent. Of course, these two angles are also congruent. Then this becomes isosceles trapezoid. Similar to isosceles triangle. Isosceles triangle, you have two pairs that are congruent, right? Two sides that are congruent. So here, if you have this side and that side are congruent, we call that isosceles trapezoid. Okay. All right. How about kite? What is a kite? Kite has two pairs of sides. Okay, and each pair is congruent. So this pair and that pair is congruent. A little bit different from the rhombus, right? For rhombus, you need to have all four sides congruent. But to be a kite, you can have two pairs that are congruent. So one pair is congruent and the other pair is congruent. But they are not opposite to each other. So this and that is a pair which are not opposite, but they are side by side. Okay, they're consecutive. Okay, and I also have put several properties here. So the angles where the two pairs meet are equal. So this pair and that pair meets here and there, right? So this angle and that angle has to be equal. And the diagonals of the kite, they meet at 90-degree angle. So they're perpendicular. Okay, they're perpendicular. Another thing is, oh yeah, bisecting. Okay, so one diagonal bisects the other, which means this diagonal, the vertical diagonal, make this horizontal diagonal into halves. So this side from here to this bisecting point, that length is the same as from here to the other side. Okay. All right. So that is a kite. So here I'm summarizing the quadrilaterals. We talked about square, rectangle, parallelogram, trapezoid, rhombus, and kite. What does square mean? To be a square, you need to have all sides congruent. All sides have to be congruent. Also, all angles have to be congruent as 90-degree angle. To be a rectangle, you need to have all angles that are 90-degree angles, right? How about parallelogram? You need to have two pairs, one pair and two pairs that are parallel. The opposite sides are equal and they are parallel. So this pair is equal length, right? They are congruent and parallel. And these two, this pair is congruent and they are parallel. To be a trapezoid, at least one pair is parallel. The other, it doesn't have to be, but if it is a parallel, it is trapezoid, but also it's a parallelogram. Okay? To be a rhombus, you need to have four equal sides. The angles doesn't matter, but the sides have to be same to be rhombus. But for rhombus, the opposite angles are congruent. Okay? To be a kite, not opposite sides, but consecutive sides. So these two sides are congruent and these two sides are congruent. Okay? Then the opposite angles here, where two pairs meet, are congruent. Also, the diagonals bisect each other and they are perpendicular. Okay? So here is a hierarchy among triangle, quadrilateral. Of course, polygon includes more than triangle and quadrilateral. There's a pentagon, hexagon, heptagon, octagon, and so on. We're talking about only triangle and quadrilateral for elementary level. So for triangle, you need to classify the triangles by the length. If no lengths are equal, we call that scale-in. If at least two sides are congruent, we call the isosceles triangle. I said at least two sides are congruent, right? Then if all three are congruent, we call that equilateral triangle. For quadrilateral, there's a kite and trapezoid. How do we classify these two? Kite, you need to have adjacent sides that are congruent. So there are two pairs of that adjacent sides are congruent. That is a kite. Trapezoid, at least one opposite pair is congruent. If you have both pairs congruent, we call that parallelogram, right? Isosceles trapezoid, you need to have the sides that are not parallel, they are congruent. Then it's called isosceles trapezoid. And it is parallel and it's also, the sides are also the same, then it becomes rectangle, right? For rhombus has parallelograms characteristics and kite characteristics. You have all four sides that are congruent. If four sides are congruent and all four angles are congruent, then it becomes a square. So it is very important to know this hierarchy, okay? Especially the teachers. Teachers have to know to teach the students. I think we can pause here. So when you come back on Monday, we will work on symmetry, okay? All right, thanks for the patience, guys, and hopefully they fix it by Monday and we can work on this in the classroom. Okay, have a good weekend.